Buongiorno da Roma. Welcome to Iccrom. Today we're going to learn about concrete.
Concrete, a transformative material that has profoundly shaped our lives unlike any other. As we stand here today in front of this timeless architectural beauty, the Pantheon, we must recognize the role that Roman engineers played in the development of this material. Over 2,000 years ago, the Romans pioneered the use of concrete, what is the closest to our modern concrete of today. They developed a recipe that included mixing and blending kiln-dried lime with sand and water, incorporating also natural compound of iron oxide and silica aluminum and rubble, creating a durable material that could cure and harden independently of the air and indeed also underwater. They employed this material to make the first concrete walls, infrastructure, and the most spectacular survival of Roman concrete today is the soaring dome of the Pantheon, completed in 125 CE. Although our admiration for ancient Roman engineering endures today, our episode will focus on and explore modern concrete. So we will come back to the Pantheon another time. 2024 marks 200 years from the invention and patent of our modern Portland cement, one of the key ingredients that make up our modern concrete. Portland cement was invented and patented in England by a bricklayer named Joseph Astin of Leeds in 1824. Astin obtained this material by burning powder limestone and clay in his kitchen stove. With this crude method, Astin laid the foundation to our modern concrete. Today, concrete is the most widely used substance after water. In these 200 years, concrete became the architectural symbol of technological modernity. It was improved and then reinvented by architects and engineers to produce a new modern architecture of diverse expression and global influence and spread. Concrete was the material of choice of superhero architects and engineers like Le Corbusier, Pierluigi Nervi, Eero Saarinen, Richard Neutra, just to name a few. Described by Frank Lloyd Wright in 1928 as having neither story nor song, concrete has long been universally valued for its strength and durability, yet no single aesthetic can describe its nature, given its ability to be formed in a multitude of methods, shapes, and form. Let's now go back to our lab and see how concrete is made and how it works. We're now back in the lab, and we're gonna try to learn how concrete works and how it's made. Concrete, it's an artificial composite material made of different ingredients that are assembled together in the field. The unique nature of this material is that, on one end, concrete symbolizes modernity. It was the material of choice of modern architecture, and indeed it has helped shape our modern city and infrastructure in the past 200 years like no other materials. But on the other hand, concrete retains this modern character to it. Assembled entirely in the field, it relies on the quality of the craftsmanship for its final aesthetic, appearance, and ultimately performance. For this reason, it's very important to understand how it's made. Let's now take a closer look at all the ingredients that make up concrete. Here we start. We have our Portland cement, which is our binder that keeps all the ingredients together, which represent between 10 to 12% of the mix. Then we have our aggregate, we have our fine aggregate and our coarse aggregate, which represent between 60 to 75% of the mix. And then finally we have water. So when making concrete, if you think about it, it's very similar to cooking. Each ingredient plays a different role, and the ratio, the proportion between the ingredient, it's important. For concrete, the water-cement ratio, it's crucial because it affects its workability, its properties, and ultimately its performance. So, although it appears as a very simple recipe, there is quite a level of complexity that goes into making concrete. So, how do we turn these 4 ingredients into a solid compact material? Through the process of hydration, which allows concrete to harden, moving from a liquid to a solid state. Portland cement does not cure through the drying or evaporation of the water, but thanks to a chemical process called dehydration, where cement reacts with water, hardens, gains strength to form the rock-like mass known as concrete. Remember, the hardening process continues over years, which means that concrete gets stronger as it gets older. For the hydration process, it's very important to control and do a proper hydration of your concrete during the curing process. So now you might be wondering, if cement and water equals to hardening, what is the real need for the fine and coarse aggregate? Let's take now a closer look and try to find out. What do coarse and fine aggregate really do in concrete? Aggregates in a concrete mix represent between 65 to 70%. They're made of geological material, which includes gravel, sand, crushed rock, and they're generally sourced locally. The use of aggregate in concrete first helps reducing the amount of cement that you need in your mix, which that helps to keep the cost of concrete production down. But more importantly, aggregate helps to obtain a more compact mix. They also help with different mechanical properties to the concrete, and they can also help with shrinkage and cracking of the concrete. When selecting an aggregate in your mix or a combination of aggregate, you select usually for different characteristics. And one also, it's the ability to receive finishes. Because if we think about an exposed aggregate finish, you really want to carefully select your aggregate because you're going to obtain different aesthetics. When referring to aggregate grading in concrete, we usually have 3 main categories: a well-graded, a poorly graded, and a gap-graded. So now think about it. A well-compacted mix usually has a well-graded aggregate mix. Now it's time to get our hands dirty. Finally, we're going to start mixing some concrete. In the exercise today, we're going to understand the important role that water plays when making concrete. We're going to prepare different mixes using different water-cement ratio. Obviously, the more water you add, the easier it is to flow. But this added workability definitely comes with a cost. Now, get your gloves, it's time to get to work. During this exercise, from the initial mix to the final one, we gradually increase the water content, starting with a low water-cement ratio of approximately 0.3 for the first sample, resulting in a notably dry mix. For the next samples, we systematically added more water, increasing the water-cement ratio, with the last mix exhibiting a soupy and a very wet consistency. Chuck, we got to the end, and definitely we got our hands dirty here in Rome. Hope that with this simple exercise you understood that when making concrete, the proportion between the different ingredients makes a big difference in the performance and in the properties of this material, in particular water-cement ratio. So I want you to bring home 2 lessons today. If you're working on a concrete heritage structure and you are designing or you're about to carry out some concrete repair, remember, first, understanding and determining the original recipe, the original ingredients of the existing substrate, existing concrete, when developing a patch repair, it's very important. And second, that when working with concrete and performing concrete repair, the quality of the craftsmanship in the execution of the work, it's crucial for the success of your work. So, we're gonna let this baby harden and we will test them later after we enjoy some carbonara here in Rome. It's time for a break. We will continue to deepen our knowledge in this fascinating material that is concrete in the next episodes. So hope you enjoy this one for now and stay tuned and ciao ciao from Rome.